Greetings. Welcome to Swayam Online Learning Portal. I am Dr. S. Ishwari, Head of the Department of Geography, Madras Christian College. In the previous lecture, we have discussed about solar radiation. In this lecture, we will be discussing on atmospheric heat budget. So, what is meant by atmospheric heat budget? So, before entering into the discussion, elaborate discussion, what are all the contents we are going to discuss in this lecture? They are: what is atmospheric heat budget, how it varies with the latitude, season and time of the day, and how it is controlled by sun's angle, clouds and atmosphere, and how it regulates the temperature, weather and climate, and how it is essential for life, agriculture and solar energy. So, these are all the contents we will be discussing in this lecture. So, what is meant by heat budget? So, in general, what is meant by budget? So, that is income, expenditure. So, if there is income, there will be expenditure. So, income and expenditure to be balanced. Okay. So, that balance to be there. So, this we will be following in our day to day life, but nature is also following the heat budget in nature. How? That is the net balance between incoming solar and outgoing terrestrial energy. So, we all know that incoming solar energy is also coming to the earth's surface, and from the earth's surface outgoing terrestrial radiation is also reflected or emitted back. So, this two should be balanced. So, that balancing budget is discussed in this lecture. That is, the insolation received at the top of the atmosphere is 100 units. So, imagine that is 100 units. So, in this, while all the 100 units will be coming to the earth? No. While passing through the atmosphere, some amount of energy is reflected, some is scattered and some is absorbed. So, these are all the important process or the factor which interrupt the or disturbs the incoming solar radiation or outgoing terrestrial radiation. Only the remaining reaches the earth's surface. So, after taking all these things, after meeting all these processes, the balance will be reaching to the earth's surface. Roughly 35 units are reflected back to the space. So, imagine that is 35 units. So, this is the most important here. So, how this 35 units have been reflected back to the surface? That is 6 units is scattered. So, 6 units it scattered to the space and 27 units reflected back to the space, and 2 units, that is from the snow ice covered areas, what happened? It is also reflected back to the space. So, this you can that is add all these 6 units, 27 units, 2 units altogether, this 35 units out of this 100 units have been reflected back to the space. Then the reflected amount of radiation is called what? Albedo. In the previous lecture itself, we have discussed that albedo plays an important role in the radiation, that is heat budget. So, this albedo concept is most important. That is, out of 100 units, the 35 units have been reflected back to the space. So, balance is what? Remaining is 65 units. So, with this 65 units, what is happening? That is 65 units absorbed. Okay, it is absorbed by the atmosphere and earth surface. So, how the 65 units have been spent? That is 14 units within the atmosphere it is absorbed, and 51 units it is absorbed by the earth surface. So, 14 plus 51, that is 65 units have been absorbed by both atmosphere and earth surface. The earth radiates what? It radiates back the 51 units. So, this 51 units, what it absorbs, it is again reflecting back to the what? That is atmosphere. Atmosphere, it is very beautiful that while incoming solar radiation comes and cross the atmosphere, it is receiving some energy, it's having some, it's gaining something, and while terrestrial radiation going back to the atmosphere towards the space, it is also gaining something here in the atmosphere. So in such a way, the atmosphere have the major role in the heat budget. And then this terrestrial radiation, we know that terrestrial radiation means the radiation which is radiated from the earth's surface. So this 51 units, 17 units is radiated to the space directly, and 34 units are absorbed by the atmosphere. So this is the major concept for the 51 units, and this atmosphere absorbs 34 units, that is 6 units absorbed directly by the atmosphere, and 9 units have been absorbed in the form of convection and turbulence, and 19 units is through latent heat of condensation. This latent heat of condensation is a catch here. This is a major concept. We will be discussing this latent heat in elaborate way in the upcoming lectures. So this 34 units have been distributed in such a way, that is 6 plus 9 plus 19, altogether 34 units is absorbed by the atmosphere. Here finally 48 units. So 48 units is also absorbed by the atmosphere. So this 48 unit, how it is absorbed? That is 14 units from the insolation, incoming solar radiation, and 34 units by the terrestrial radiation, that is outgoing radiation. So this 48 unit is spent. So altogether, while you calculate it, see the 17 units by the earth is radiated back to the space, and 48 units by the atmosphere. So totally the 65 which we have earlier is balanced. So this balancing effect is known as heat budget or heat balance of the earth. So in order to understand this concept easily, the total unit is 100 units, that is solar radiation. The green color arrow marks represent the that is the absorption by the earth's surface, that is reaches the earth, that is 65 units. Already we have the 35 units directly which have been sent to the space. Okay. So the reflected back to the space. So leave this 35 unit. So we have to balance this 65 units alone. How we are going to balance it? 14 units have been absorbed by the atmosphere, and 51 units have been absorbed by the earth's surface. And again the 34, from this 51 units, 34 units have been absorbed by the atmosphere. So this 14 plus 34 is 48 unit. Okay. So this 48 unit, again what have to be done? It have to be radiated back to the space, because it have been received, again it have to be sent. So meanwhile what happened? This from the 51 units, it have been radiated 17 units to the space earlier. So this 48 plus 17, altogether 65 units is balanced. So what is received? 65 units, and what is again sent back? 65 units. So in these are all the process in which the heat is balanced, absorption and then reflecting back. So this is the concept which have been done. This major concept is known as heat budget or heat balance. What are all the components of heat budget? The components of heat budget is incoming solar radiation. So we know that incoming solar radiation is known as shortwave, and outgoing terrestrial radiation is known as longwave. So the reflected radiation, the term which represent albedo effect. So this reflected radiation is also one of the major component. And observed radiation by the surface is observing and atmosphere is observing. And outgoing long wave radiation, that is infrared. So what we have discussed in the earlier lecture, IR, infrared. And heat transfer. So once it is received, the heat should be transferred. So the heat transferred by what are all the process which involve in the transferring the heat? That is conduction, convection latent heat. So, these are all the processes which involved in the heat transfer. So, these are all the components of heat budget. Albedo. So, as this albedo is a special case, so which involved in major processes, so we have to know what is meant by albedo, what is the role of albedo. The portion of the incident radiation, that is energy reflected back from the surface of a body, is called albedo or reflection coefficient or simple reflectivity. So, these are all the terms which represent what? Albedo. So, if the question is asked in by, that is simple reflectivity or reflection coefficient, it is representing what? Albedo only. So, do not get confused. It plays a major role. So, albedo effect, that is the reflecting back, is not equal in all surfaces. See here in the picture, that is the highest albedo is reflectivity is by fresh and dry snow, and then see the lowest albedo effect is from fresh asphalt and then the, open ocean averages. So, you have highest albedo and then lowest albedo. So, this highest lowest range can be asked in the competitive exams in ascending or descending order. So, make a note of it. It plays a major role in the energy balance of the Earth's surface, as it defined as rate of the observed portion of the incident solar radiation. So, the snow, ice, high albedo, which reflects most of the energy, and forest soil have low albedo, which absorbs more energy. So, this is the major concept of albedo. Solar constant. So, solar constant is also, as albedo, is also plays a vital role. The average solar radiation at the top of the atmosphere is known as solar constant. How it is measured? 1361 watts per square meters. It slightly varies during what? Solar cycle, that is once in 11 years, and then the constant, it's constant over a short periods, and it is also important driver for what? The Earth's energy budget. So, energy is mainly because of solar constant. If it is affected, what happens? The seasonal heat distribution is also affected. Solar radiation spectrum. The solar radiation spectrum. The solar radiation is in the form of electromagnetic waves or electromagnetic energy. So, that radiation spectrum, so that is shortwave radiation, that is a visible, UV rays and near infrared. So, in these waves, the solar energy, that is solar radiation spectrum, is distributed. The peak is visible in the spectrum, that is 0.5 micrometers, and ultraviolet radiation is observed mostly in stratosphere. So, you know that the stratosphere, troposphere, which is the layers of the atmosphere, this layers have been heated by the solar radiation. So, often we have the vertical temperature distribution, in that we have discussed this concept. The infrared absorbed by the atmosphere as well as the clouds in the atmosphere, which also determines the surface heat efficiency. So, this is about the solar radiation spectrum. Next one is the atmospheric absorption. So, absorption, you all know that how, what all the agent which absorbs the atmosphere, atmospheric that is atmospheric gases like ozone, water vapor, carbon dioxide, and which absorbs the solar radiation. So, warming effect, that is it's by the troposphere and stratosphere, which have the warming effect because of these gases, and it also reduces the energy reaching the surface. So, it acts as the protective agent, that is atmosphere acts as a blanket for the Earth's surface. It is a driving force for the atmospheric circulations like planetary wind and other wind which blows is affected by the atmospheric absorption. It is also important, it plays a vital role in greenhouse effect. The next is the seasonal and latitudinal variation. So, the seasonal and latitudinal variation of this heat budget, how it involves, that is solar intensity. The solar intensity based on the latitudes. If it is going to be a lower latitudes, the intensity will be high. If it is going to be a higher latitudes, the polar region, the intensity will be low. How it influences it? It influences the monsoon of the region, that is monsoon region climatic condition, and then the climatic zones also affected by the solar radiation. Next one is long wave radiation. So, long wave radiation is also known as what? Terrestrial radiation. The earth emits infrared radiation to the space. So, that is this red color arrow marks is the long wave radiation, which is radiated from the earth's surface towards the atmosphere as well as the space. It depends upon the surface temperature. Once it is received only, it can give back. If there is no radiation, if there is no temperature receivance, then there is no the again reflecting back effect. The major component is the heat loss. So, once it receives, it gains the heat, that is earth's surface gains the heat. Once it reflects back, it loses the heat which have been gained. It is partially absorbed by the greenhouse gases. Not all the emitted rays, infrared rays have been absorbed by the atmosphere or greenhouse gases which is present in the atmosphere. Partial radiation, terrestrial radiation, infrared radiation have been absorbed by the greenhouse gases. Greenhouse effect, that is the gases trap the outgoing radiation. See here, this is the layers of the atmosphere, that is in the atmosphere you have various gases. So, that gases like greenhouse gases which traps the, that is whatever the radiation, incoming radiation or outgoing radiation. So, it traps it. The carbon dioxide, methane and water vapor which is present in the atmosphere, what happens? It plays a vital major role in trapping it. It is essential for, if it does not trap, what happens? So, it will, the earth's surface will not be feasible for the biolife. So, it is very much essential for habitability. The excess cause of global warming, it is also a part of greenhouse gases. If it absorbs, that is this greenhouse gases like carbon dioxide, methane, water vapor, if it does not absorb the gases, that is terrestrial radiation, what happens? The excess heat will be there in the earth's surface, which will not support the life forms in the earth's surface. If it is also essential for what? The habitability. The excess causes of global warming is also done because of this gases, greenhouse gases. It modulates Earth's heat budget. So, by receiving it and reflecting back, by absorbing it, all these processes which regulates the Earth's heat, Earth's temperature. Clouds and aerosols. The clouds reflects the solar radiation which in turn cools the Earth's surface, and the clouds also traps what? Infrared radiation, that is the radiation from the Earth's surface. It provides what? It provides warming effect. So, the cloud reflected means it is a cooling effect. If clouds trap, it is a warming effect. The aerosols always scatter the sunlight, and the net effect varies with the type and height of the clouds, what type of clouds present in that particular region and in what height it is present. So, all these things determine the sun radiation, refraction or absorption, what the scattering. So, all this process determined by this net effect. It is also significant in the regional energy budget. So, overall it is the energy budget, that is heat budget, which we have discussed is overall heat budget. So, each and every place have its own regional energy budget. So, this clouds and aerosols plays a important role in the regional energy budget. Radiation balance. So, how this radiates? In the name itself, balance, that is equilibrium. Equilibrium of what? Incoming and outgoing energy. There should be a balanced incoming and outgoing radiation energy. It deviates, if it deviates, what happen? Either it will be too warm or it will be too cold. So, this contrast effect will be there if the equilibrium is disturbed. The energy is surplus in what? In the equator region. Energy is deficit in pole side, polar region. So, because of this, it drives the global heat transport. From the excess region, the energy is transferred to the deficit region. From the deficit region, there is a flow of the air masses. These concepts you will be understanding in the pressure, atmospheric air pressure belts. The next one is radioactive forcing. So, radioactive forcing is a measure of energy imbalance which have been caused by various factors. That is, it may be a natural factor or it may be anthropogenic factor. The natural factor, how it disturbed it? The natural factors such as volcanic eruption and then solar variation plays an important role in this radioactive forcing. And then this anthropogenic activity, that is human impact, that is greenhouse gases and aerosols which have been emitted or which have been generated by human activity, also plays a vital role in this radioactive forcing. So, it have two forcing, that is positive forcing and then negative forcing. The positive forcing which results in warming, negative forcing which results in cooling. So, this warming and cooling balance have been generated because of natural factor as well as the anthropogenic factor. The next one is the conduction. The conduction is the direct heat transfer through contact. So, something is transferred. What is that? Heat is transferred through direct contact. So, this is known as a conduction. The surface warming is done by soil, water and rock. So, the soil, water, rocks plays a vital role in conduction, conducting the heat. The minor role is played by the atmosphere which is above the earth's surface. The important of this one is it is important near the surface. So, this conduction is important near the surface region and it drives the local temperature changes. Next one is convection. So, what is meant by convection? The heat transferred by the fluid movement. So, there is a liquid movement, fluid movement. Because of this, the convection process has happened. It drives the vertical motion. So, you can see here the warm air and then cold surface, warm surface, cold surface, warm air rising and sinking of cold air. So, this fluid movement is known as what? The convection. That drives a vertical motion of atmosphere. It creates the weather system. So, because of this only the local weather, the day to day or hourly basis weather activity, weather process happens because of this convection. The transfer heat from the surface to the upper atmosphere, where these fluid movement is traveling. It is traveling from earth to atmosphere, atmosphere to earth surface. It is mainly useful for what? It is significant in tropics, tropical region and mid latitude region. So, in such a way, this because of the heat, the generation of heat and then the precipitation which makes this process more vibrant. Next one is advection. So, advection is nothing but the horizontal heat transport by wind. So, the wind is moving horizontally, either it may be a warm air advection or it may be a cold air advection. The movement of warm and cold air across the region, it will be traveling from one region to another region. Because of this, what happens? It influences the climate of the continent. It is also important in monsoon and cyclonic formation, and it redistributes the energy globally. So, the movement of air plays an important role in the advection process. Next one is latent heat transfer. So, latent heat transfer is heat is absorbed, released during the phase of change. So, in each and every process, the heat is either absorbed or released. So, in the heat budget, what we have discussed, the absorption of either air surface or atmosphere, and then reflection, release of either release from the earth surface or from the, that is, atmosphere. So, that particular transfer of release and absorption process has happened because of this latent heat transfer. These process, latent heat will be occurred in evaporation, condensation, freezing and melting. So, in all these processes, what is most important? Latent heat is most important, which drives vibrant in clouds forming because of this jet streams. What all the contents we are going to discuss in this jet streams? Jet streams. What all the contents we are going to discuss in this jet streams? Jet streams. What all the contents we are going to discuss in this jet streams? Clouds. It is also important in the atmospheric circulation. So, because of heat transfer, there is a atmospheric process, and which in turn which supports the weather processes. Latitudinal heat balance, that is, you all know that equator energy is surplus and in poles the energy is deficit, which drives the meridional heat transfers. So, each and every meridian also the heat is transferred. So, because of this, what happens? There is a ocean current. So, because of this latitudinal heat imbalance, what happens? There is a ocean currents. It also balances the global temperature. So, here you can apply the concept of continentality and coastal region, that is moderate climate. So, this imbalances in the heat is mainly because of this solar radiation difference. Net radiation concept. The next one is net radiation concept, that is difference between incoming and outgoing energy. What is the difference? Either all the energy is coming, is reflected back. What is the major difference? So, that is known as net radiation concept. There is a positive net radiation and negative net radiation. If it is a positive net radiation process, it will be leading to warming effect. If it is a negative net radiation, it will lead to cooling effect. It is one of the important factor which determines the local energy balance studies. So, this is one of the major one for local energy balance studies, and based on this the meteorological measurements have been done, and it also varies in a diurnal and seasonality. So, in seasonally and in day to day, this net radiation is differing. So, because of that, there is a concept, that net radiation concept evolved. The next is atmospheric composition. So, atmosphere have various composition. So, in the composition of atmosphere, we have discussed it. The main thing is that the work of the greenhouse gas is to trap the heat, and aerosols is another one of the main particles which is present in the atmosphere. What is the main work of the aerosols? That is, it scatters the sunlight. And water vapor, which dominate, and water vapor is main because of the latent heat exchange. It dominates in the latent heat exchange. And the next one is pollution. Due to pollution activity, what happens? It modifies the radiation balance. It is also important in the climate change scenarios. This atmospheric composition is one of the major factor for the climate change scenarios. The next is climate zones. So, you know that there are so many zones. Based on the latitudes, you have zones. The energy budget shapes this climatic zones. How the climatic zones have been classified? That is tropical zone, temperate zone and polar zones. So, based on the energy only, that is solar radiation only, these zones have been classified. it also determines the precipitation patterns. So, if there is a temperature is high, it leads to the precipitation. The convection will be happening, because of convection process there is a precipitation, and it also influences the vegetation. If there is a optimum temperature and rainfall, so automatically it supports the vegetation growth. And there is a seasonal shift in the radiational impact weather. Each and every season have its own unique features: summer, winter, spring, autumn. So that's elaborated here, and there is a significant effect on agriculture planning. So, if you know the concept of this heat balance as well as the climatic zones, it is very much helpful in agricultural planning. The next is ocean currents. The ocean current is that the surplus energy is in the equator, and because of that the warm ocean currents are mainly flowing in equatorial region. Equatorial region have the warm currents, and that it deflects at the pole. So, in the polar region what happens? The cold current will be there. Because of cold condition in the polar region, the cold currents will be there. So, warm current in the equatorial region and cold current in the polar region. So, it redistributes the heat globally. So, transferring or movement of these warm and cold ocean current, which have balancing effect on the entire heat budget. That is, it also affects the coastal climate. Affect in the sense, it has the moderate climate in the coastal region and the adverse effect in the continental interiors. It links to the monsoon and El Nino events. So, the ocean current is also one of the major factor which is most responsible for monsoon as well as the El Nino patterns events. The extreme weather events. So, the atmospheric process is directly correlated with what? Weather events. So, weather events, extreme weather events. If there is no balance solar radiation or no balance heat budget, what happens? It leads to the adverse or extreme weather event, that is imbalance in this heat wave and cold wave, which leads to extreme weather event. Energy surplus, which drives the cyclone effect, and hurricanes, which forms in the warm ocean surface. So, these are all the extreme weather event because of the imbalance of heat and cold waves. The drought condition is also linked to the energy redistribution. If there is no proper balance, adversely it leads to the drought condition. So, it can be predicted with the help of the heat budget models. There is a model which supports, and because of that model we can mitigate this extremes, or we can predict this we can manage this extreme weather events. Climate change impact. How the climate change is impacting because of this heat balance is no imbalance of heat, that is rising greenhouse gases, which leads to what? Positive forcing. So, in the previous slide we have discussed about positive forcing and negative forcing. So, positive forcing means warm effect, negative forcing means cool effect. The global warming, which increased with the increase of long wave radiation. So, terrestrial radiation which is going to the atmosphere, which in turn leads to the global warming. If it is going to be very high, it leads to the global warming. If the melting ice is going to melt, what happens? It alters the albedo. So, albedo level is high in the melting ice. The changing seasonal and latitudinal heat balance is also directly affect the climate change. It impacts the, if there is a change in the climate, it impacts the ecosystem and human activities. Importance of heat budget. What is the importance of heat budget? It regulates the climate and weather pattern. So, if there is no balance, imagine if there is no balance in the heat, what happens? The bio life forms will not be in the earth. It does not support the life forms in the earth, and the entire circulation process will be collapsed. So, what is much needed, that is heat budget is much needed to regulate the climate and weather patterns. It also drives the atmospheric circulations like easterlies, westerlies, polar winds. So, all these wind circulation, air circulation is mainly because of this heat budget. It also influences the ocean currents and the evaporation processes. The water cycle is also major process which is because of heat balance. It affects global temperature trends and it is also one of the basis for the climate change studies. So, to sum up with the entire concept, the solar radiation received at the Earth's surface varies with the latitude, season and time of the day, and with the maximum intensity at the equator and minimum intensity at poles. It is controlled by various factors such as sun's angle, cloud cover, atmospheric condition. This variation regulates temperature, weather and climatic pattern, and it's essential for sustaining life, supporting agriculture and enabling solar energy use. I hope you understand this concept. In upcoming lecture, we will be discussing on atmospheric heat balance. Thank you.